In the class, we're here tonight to look at converting numbers from the decimal system into other systems. Specifically, we're going to focus on the hexadecimal system as our other system. So just a real quick reminder on some things we've looked at in the past. Let me go up here and find this. Here we are. The hexadecimal system has place values of 4096, 256, 16, and 1's place values. Something else to recall, and in fact I'll write this down here where we're going to do our examples. We'll just write it right in here. Something you got to remember here is that in the hexadecimal system, since it is a base 16 system, we actually have to use some letters to represent numbers. So in this case, the letter A actually represents the number 10, B represents 11, C 12, D 13, E is 14, and F is 15. And of course, these are sometimes known as ciphers. These ciphers, A, B, C, D, E, and F, represent the numbers 10 through 15. So we're going to keep that in mind. We may need to use that. So let's take a look. What we are here at the top, what we need a number to equal up to 308 in the base 10. So I like to start off by remembering that my total has to be 308. So whatever values add up in this region has to add up to be this 308 down here. So clearly, if I have a 1 in the place value of 4096, that's going to be way too much. So I know that I'm not going to need any of those. If I had two 256s, that's going to be too many. So 1 is going to be the right amount. So 1 times 256 gives me 256. And let's see, how many are left? After I have a 256, 308 minus 256. I'm just trying to figure out what I have left here. And that gives me 52 is left over. So let's see, 16. If I had two 16s would be 32. That's probably not enough. 3 16s would give me what? 48. So that sounds about right. So I'm going to need 3 of those. That's going to give me 48. So let's see, how much is left? 48. That's going to give me 4, isn't it? So in the 1's place value, to get a 4 here, I'm going to need to have a 4 in the place value there. So just to double check, let's make sure this all adds up. Let's add my numbers here. We get 256 plus 48 plus 4. And hopefully that's going to equal 308. And there it is. So, written out here, 308 base 10, in other words, a decimal number, is equivalent to 134 as a base 16 number. So this would be 308 written as a hexadecimal number. Let's look at a second example. So here we are at our second example. Our goal here is to take the 428 and convert it into a hexadecimal number. So once again, I know that whatever place, how many digits in the place value I have here is what has to add up to be the 428. So I'm going to start with my largest place value, which is the 4096 place value. Clearly, one of those is going to be too many. So I'm not going to need any of those. 256, if I do 2 of them, I'm going to get over 500. So that's going to be too much. So I know I'm going to need one of them. 256. All right, so let's just see, how many do I have left here? 428 minus 256. Let's see, we're going to have a 2 there. We're going to have to, or what would we get? 172, right? So I know I have 172. 10 times 16 gives me 160. So that sounds about right. All right, now notice that 10 in the hexadecimal system is actually an A. So we're going to need A in this place value. That's going to give me 160. Remember that A here represents 10. So this number here is actually like a 10. Let's see, what am I left with here? I have 160. So subtract these two. What do we get here? We get a 1 and a 2. We get 12. So in my ones place value, that's my last place value right here. In my ones place value, I know I'm going to have 12. What's 12? Well, 12 in the hexadecimal system is a C. So I'm going to have C amount of ones. That's going to give me 12. Let's just double check and make sure this adds up properly. 256 plus 160 plus 12 should equal 428. So to write 428 as an hexadecimal number, it's going to actually be, we write our place values up here. We're at a 0, which doesn't really have to be written, but I'll write it. 1, A, C. And this is a base 16 number.